Hello students, welcome back. Students, today we are going to start a new topic, that is properties of salts. So students, the main properties of salts are, now first is their nature. Now students, a salt is a combination of basic radical and acid radical, that is cation and anion. It means a salt is composed of ions which are held together by strong electrostatic forces of attraction, which means all salts are electrovalent compounds. Now students, because of presence of strong electrostatic forces of attraction, the melting and boiling points of salts are much higher than the room temperature. So we say at room temperature they are non-volatile solids. They are non-volatile solids, which means they do not form vapors at room temperature. And thirdly students, they are crystalline in nature. They are crystalline in nature, which means that the arrangement of say one ion around the other ion is definite, means salts have a definite crystalline structure, means they have a definite geometrical shape. So this was our first property. Now students, second property of salt is their electrical conductivity. Now students, we have learnt this also, that salts are non-volatile solids, and this is because of presence of strong electrostatic forces. So in solid state, that means in solid state they are non-conductors, means they do not conduct electricity. Now this is because in solid state these ions are held firmly by the strong electrostatic forces, so they are not mobile and therefore salts do not conduct electricity in solid state. However, in molten state, that means in fused state or in aqueous solution, the dissociation of ions takes place. That means these ions, they get dissociated and therefore these ions become what? Mobile, or we say free. So in molten state or aqueous solutions, ions are free and mobile, and therefore we say that salts conduct electricity in molten state or aqueous solution. So in molten or aqueous solution they behave as conductors. Now students, third property of salts is their solubility. Now students, generally we say that salts are polar compounds. This is because each formula unit of a salt has what? A positive end and a negative end. So because of this polarity, salts are generally soluble in water. So most of the salts are soluble in water. But students, let me tell you that the extent of dissolution of a salt or salts is not same. Means some salts are highly soluble, some salts are very less soluble, some are partially soluble. So depending upon solubility, salts are of three types. So depending upon solubility, we have three types of salts. First, soluble salts. First we have soluble salts. Now students, soluble salt क्या होता है? Now listen carefully. If 1 gram or more amount of a salt dissolves in say 100 milliliters of water, we say salt is soluble. So whenever the solubility of the salt, say per 100 milliliters, is equal to or greater than what? 1 gram, we say salt is soluble. Now second type of salts, they are called say partially soluble or partly soluble salts. Now students, if suppose less than 1 gram of the salt dissolves, we say It is partially soluble. So partial soluble salts are those which have solubility in the range 0.1 gram to 1 gram. So per 100 milliliters, अगर आपका 0.1 ग्राम से 1 ग्राम तक डिसॉल्व करता है, we say salt is partially soluble. And then we have third type of salts which are called almost insoluble or sparingly soluble salts. Now students, if solubility of a salt, say per 100 milliliters of solution is less than 0.1 gram, so if solubility of a salt per 100 milliliters of solution is less than 0.1 gram, means एक negligible amount dissolve करता है, we say salt is insoluble. So students, this was our third property. Now we are going to start a property which is most important, and it is salt hydrolysis, means hydrolysis of salts. So students, first you have to understand what do you mean by hydrolysis of salts, or simply what is salt hydrolysis. So hydrolysis of salt. Now students, I'm giving you one reaction. Say I have an acid HX. So this is, say, acid, and I have a base MOH. Here M is a, say, metal ion, and we know that acid and base react to give salt. So this MX is a salt, and then water only. Now students, this reaction is called neutralization reaction. So this we have learnt that when acid and base react to give salt and water, this reaction is called neutralization. Now students, I'm writing another reaction where I have a salt MX, and in water, see, we get MOH and HX, that is base and acid. Now students, when we look at this reaction carefully, we observe that this reaction is what? Reverse of neutralization. This reaction is what? This reaction is reverse of neutralization. And students, this reaction which is reverse of neutralization, this is actually called salt hydrolysis. This is called salt hydrolysis. Means सिंपल वर्ड्स में अगर मैं कहूं तो सॉल्ट हाइड्रोलिसिस एक्चुअली देखने में आपको न्यूट्रलाइजेशन का ऑपोजिट लगेगा. नाउ स्टूडेंट्स, एक्चुअली होता क्या है? एक्चुअली व्हेन वी डिसॉल्व अ सॉल्ट इन वाटर, फर्स्ट डिसोशिएशन occurs into constituent ions, and then what happens is that we know that water is what? A polar compound. Water is a polar compound. H has a slight positive charge and oxygen has slight negative charge. So these ions in the solution, they start interacting, like this X negative now will interact with H positive, and this M positive will interact with OH negative, and this causes splitting of or breaking down of this, and H and X combine to give HX, which is acid, and then M positive combines with OH to give base. So this reaction is called salt hydrolysis. Now how to define this process? So students, listen carefully. Salt hydrolysis is a process in which the acid and basic radicals of salt, so this is basic radical, this is acid radical, that is cation and anion of the salt, interact with water, producing an acidic solution, or basic solution or neutral solution. So this process involving interaction of cations and anions of the salt with water, resulting in the formation of an acidic, basic or neutral solution, is called salt hydrolysis. Now students, how to predict whether solution will be acidic, basic or neutral? It is very easy, students. Now more different cases. Say if the salt, say, undergoes hydrolysis and produces, say, acid and base, and then say I have third column, nature. Now students, if say in first case the acid formed upon salt hydrolysis is strong, the base formed is also strong, then students, the solution will be neutral. That means the pH of the solution will be 7 at, say, 25 degrees Celsius. Second case I have, say, if the acid formed is strong but the base formed upon hydrolysis is weak, then students, the nature of the solution will be acidic, means pH of the solution will be less than 7. Now students, we have third case. See this now. If suppose acid formed upon salt hydrolysis is weak but the base is strong, in that case the solution will be basic. Solution is basic, that means pH of the solution will be greater than 7. And the last case students we have is that acid and base both are weak. In that case solution will be acidic, basic or neutral. That depends on what? That depends on strength of acid, because when we say acid and base are weak, if they are, say, equally weak, solution will be neutral. If they are equally weak, then solution will be neutral. But suppose if I say acid, though they are weak, but listen students, अगर मैं कह रहा हूं दो weak हैं तो ये जरूरी नहीं है कि वो equally weak हो, because a weak acid or weak base means the degree of dissociation is less than 5%. means suppose इसका अगर 4% है तो इसका 3% है, means दोनों ही weak हैं, but they are not equally weak, क्योंकि इसका मैंने 4% कहा, इसका 3%, so that means ये ज्यादा weak है. So if say acid is slightly, say, stronger than the base, acid is relatively stronger than this weak base, then we say solution is acidic. But if say base is slightly stronger than the acid, then we say solution is what? Basic. But let me tell you students, when acid and base are both weak, we generally say the pH of solution will be nearly 7. Nearly means it is either slightly more than 7 or it is what? Slightly less than 7. So this is how we predict what? The nature of solution by looking at the salt. Now students, I'll explain you why the solution obtained by salt hydrolysis is sometimes acidic, sometimes basic or neutral. Now I'll give you some examples. Say I'm taking first case where we are taking hydrolysis of salt of strong acid and strong base. So we have a case where salt is of what? Strong acid and strong base. Students, आपको यहाँ थोड़ा सा सोचना पड़ेगा. Now just think of a salt which is formed from a strong acid and strong base. Students, NaCl. Because NaCl is a salt of what? आप इसको ध्यान में सोचो. NaCl is formed when sodium hydroxide and HCl they react. So we can say that sodium chloride is a salt of NaOH and HCl. So what happens upon hydrolysis? That upon hydrolysis, which is reverse of neutralization, we get acid and base. Now, but generally what happens in salt hydrolysis, that first ions they dissociate and then they interact with water. But students, what is HCl? HCl is strong acid. And what is NaOH? Sodium hydroxide is also a strong base. And what do you mean by strong acid or strong base? Strong acid matlab it undergoes dissociate completely. So we have what? H positive and Cl negative. NaOH is also strong, which means it also undergoes complete ionization. So we have free sodium and hydroxyl ions. Now students, look, these ions, sodium ions, जैसे पहले थे हाइड्रोलिसिस के बाद भी उनका स्टेटस वैसा ही है, which means they are just spectator ions. So chloride and chloride वो भी cancel हो गया. So the final equation that we get is H positive and OH negative. Now students, see that when salt is of strong acid and strong base, neither cation nor anion undergo hydrolysis, because वो तो spectator है, क्योंकि cation जैसे पहले था बाद में भी वैसा है. So we say neither cation nor anion undergoes hydrolysis. So ultimately the equation represents what? This represents simple ionization of water, and in water we know that concentration of H positive ion and OH negative ion is what? Equal. So that is why we say solution is neutral. So student, this was our first case, that when acid or base जो salt hydrolysis से बने, अगर suppose वो दोनों ही strong है, in that case the solution will be neutral. Now we have second case of salt hydrolysis, that is when we have a salt of strong acid and weak base. Students, एक पहले मैं आपको लॉजिक बता दूं, हाउ टू प्रेडिक्ट वेदर सॉल्यूशन विल बी एसिडिक और बेसिक. दोनों स्ट्रॉन्ग है तो न्यूट्रल. बट सी हियर, विच इज स्ट्रॉन्ग? एसिड, सो सॉल्यूशन इज एसिडिक. लुक एट दिस केस नाउ, विच इज स्ट्रॉन्ग? बेस, and therefore solution is basic. So when both are strong, neutral. When acid is strong, acidic. When base is strong, basic. And when both are weak, it is almost neutral. Slightly acidic या basic हो सकता है, but otherwise solution is almost neutral. So now students will continue. We have a second case, hydrolysis of salt of what? Strong acid and weak base. Strong acid and weak base. Students, just think of a salt which is of strong acid and weak base. Ammonium chloride example हो सकता है, because ammonium chloride is a salt of what? Ammonium chloride is a salt of ammonium hydroxide, which is weak, and HCl, which is strong. So we have a salt of strong acid HCl and weak base ammonium hydroxide. Now students, when ammonium chloride undergoes hydrolysis, upon hydrolysis it will give the base ammonium hydroxide and acid HCl. Now, but actually upon hydrolysis what happens is that we are getting base. लेकिन base तो weak है. Now what do you mean by weak base? Weak base means the one which undergoes dissociation or ionization to a very small extent. So मैं क्या करूंगा, इसको मान के चलता हूं that it is almost what? Not undergoing dissociation. Though थोड़ा बहुत ionize होगा, but since the degree of dissociation is very small, I'm not ionizing this ammonium hydroxide. But HCl, since is a strong, it will undergo complete ionization into H positive and Cl negative. Now students, see, chloride ion before hydrolysis or after hydrolysis, उसके status में कोई change नहीं है, which means here chloride ion is a spectator ion, but ammonium ion undergoes hydrolysis to give ammonium hydroxide, और वो पूरा नहीं टूटेगा. इनफैक्ट मैंने बिल्कुल भी नहीं उसको तोड़ा. क्यों? Because वो तो बहुत weak है. So students, here we say only which ion is undergoing hydrolysis. See, only cation undergoes hydrolysis to give ammonium hydroxide, and then we have H positive ions. So we said this is a case of what? Cationic hydrolysis. Now students, how to predict whether this solution will be acidic or basic? See students, आप देख सकते हैं solution में H positive ions बहुत ज्यादा है, OH negative ions होंगे लेकिन बहुत कम. क्यों? Because ammonium hydroxide is a weak base and therefore it undergoes ionization slightly. So we have very few ions, HOH negative ions. We have what? A large concentration of H positive ions, and when concentration of H positive ions exceeds OH negative ions, we say solution will be acidic. In fact, logically तो बहुत easy है. अगर salt strong acid और weak base का है तो resulting solution strong acid से decide हो जाएगा. That means acidic होगा. So now students, we have a third case, that is salt of weak acid and strong base. So we have a salt of weak acid and strong base. So this is hydrolysis of salt of what? Weak acid and strong base. Now again students, think of a salt which is of weak acid and strong base. I think this sodium acetate will do. ये चलेगा because this is a salt of what? It is a salt of acetic acid which is weak and sodium hydroxide which is strong. And now we'll discuss how it undergoes hydrolysis. So upon hydrolysis, we know that hydrolysis is reverse of neutralization. So we have what? Weak acid and a strong base. Or we can write this, because hydrolysis means interaction of cations and anions with water. So we can write this equation in this manner also. Now again, acetic acid is weak, and I am assuming that it undergoes ionization to a very very small extent. That means it remains almost unionized. So मैं इसको ionize नहीं कर रहा हूं, दो थोड़ा बहुत होता होगा. Now NaOH is a strong base and therefore it undergoes complete dissociation into ions. Now see, sodium ion जैसा पहले था अब भी वैसा है, but acetate ion पहले free था, now it is not free because acetic acid is weak. So we say that in this case, which ion undergoes hydrolysis? It is anion. It is anion. So that is why students, this case is called anionic hydrolysis. This is called anionic hydrolysis. And now students, see what will be the nature of solution. This solution has many OH negative ions. So यहाँ पर OH negative ion का जो concentration है relative to H positive ion is quite high, because H positive कहाँ से आएगा? यहाँ से. But this acid is weak, so will give very few H positive ions. So hydronium ion concentration is low, and that is why the solution is what? Basic. And again by using logic, क्योंकि बेस स्ट्रॉन्ग है इसीलिए सॉल्यूशन में तो बेसिक आना ही है. सो इसका पीएच 7 से ज्यादा ही होगा एट से रूम टेम्परेचर. नाउ वी हैव लास्ट केस वेयर बोथ एसिड्स एंड say base are weak. Students, the fourth case of salt hydrolysis is hydrolysis of salt of weak acid and weak base. Now students, think of a salt which is of weak acid and weak base. Students, ammonium acetate is one such salt. Why? Because ammonium acetate, just think of its radical. Acetate radical, acetic acid से आया, so it is a salt of acetic acid. And ammonium radical कहाँ से आया होगा? Ammonium hydroxide. So this is a salt of acetic acid and ammonium hydroxide. Now students, when this salt undergoes hydrolysis, see what happens, that these ions interact with water forming weak acid, say acetic acid, and weak base, ammonium hydroxide. Now students, since they are weak, they will undergo ionization or dissociation to a very small extent. So that is why I'm writing them in unionized form, because अगर होता भी होगा ionization तो बहुत कम होता होगा. Now how to predict whether resulting solution will be acidic or basic, because वो दोनों weak हैं. Now students, it will depend upon their degree of dissociation. Say degree of dissociation of weak acid, acetic acid is alpha 1, and that of weak base is alpha 2. Now students, here we have three cases. Say if alpha 1, that is degree of dissociation of acid, and degree of dissociation of base, alpha 1 and alpha 2 are say equal. Students, in that case, क्योंकि दोनों का डिग्री ऑफ डिसोसिएशन इक्वल है, तो यहां से H पॉजिटिव और यहां से OH नेगेटिव जो आएंगे वो भी सेम होंगे. सो उस केस में हम कहेंगे सॉल्यूशन विल बी व्हाट, न्यूट्रल. नाउ स्टूडेंट्स, सेकंड केस कैन बी, से इफ alpha 1 is slightly greater than alpha 2, which means acid is slightly stronger than base. So in that case, the H positive ion concentration is slightly greater than OH negative ion concentration, and therefore solution will be acidic. And students, lastly, if say alpha 1, that is degree of dissociation of this weak acid, is slightly less than alpha 2, that is degree of dissociation of weak base, in that case students, H positive ion concentration is less, OH negative ion concentration is more, and therefore solution will be basic. So in this case, the nature of solution will depend on degree of dissociation of these two weak electrolytes. दोनों weak तो हैं, but क्या वो equally weak हैं वो देखना पड़ेगा. If they are equally weak, means the degree of dissociations are equal, neutral. If say acid is slightly stronger than base, acidic. If base is slightly stronger than acid, then basic. So students, this was a very important discussion. Now in next topic, I'll give you some examples, and from those examples we'll predict the pH of solution of that salt. Thank you students.